Welcome back. This is section 3.9 of chapter 3, antiderivatives. Okay. Before I continue on this section, I want to point out on Blackboard for section 3.9, I have uploaded the lecture slide I'm going to go through right now, as well as a particular file called basic derivatives and antiderivatives. Okay, this information is also available on Dropbox. Okay, basic derivatives and antiderivatives. Okay, so where is this available? It's available in our course along with the lecture slides. Okay, it's part of chapter 3. This is important information you will need soon. Okay, so it's available in our Dropbox as well as on Blackboard. Okay, so let's go through antiderivatives. Antiderivatives means opposite of derivatives. Okay, we'll see in a few minutes what that means. Let's go through some examples. A physicist who knows the velocity of a particle might wish to know its position, that is the opposite. You see, if you know position, its derivative is velocity. If you know velocity, can you find its position? Likewise, an engineer who can measure the variable rate at which water is leaking from a tank might want to know the amount leaked over a certain period of time. So derivative of amount over a certain period is called rate. What if you know the rate? Can you go back and find the amount? Likewise, a biologist who knows the rate at which a certain bacteria population is increasing might want to deduce what the size of the population will be at some future time. So, derivative of population is the rate of population growth or decrease, whatever. But what if you know the rate? Can you go back, find the population? That is, you want to go anti-derivative. Okay. In each case, the problem is to find a function f whose derivative is a known function. If such a function f exists, it is called an antiderivative of f. A function f is called an antiderivative of f on an interval I if capital F prime x is fx. Okay, what this means is the simple case of going back in the derivative table. So this is the file that I talked about, basic derivatives and antiderivatives. What it means is, first let's summarize the basic derivatives. I have a column here of functions and here of their respective derivatives. F is your function, f prime is your derivative. If my function is constant, its derivative is 0. If my function is x to the power n, its derivative is nx to the power n. Function is sine, its derivative is cosine. Function is cosine, its derivative is negative sine. Function is tan, its derivative is secant squared. Function is secant, its derivative is secant x tan x. Function is cosecant, its derivative is negative cosecant cotan x. Function is cotan, its derivative is negative cosecant squared. And then there are these rules for addition. Derivative of addition is, well, you take derivative of each piece and then add. Likewise, derivative of a difference. You take derivative of each piece and then take the difference. This is the product rule. Derivative of f times g. Derivative of the first, second as it is, plus first as it is, derivative of the second. You are multiplying there, you see. Likewise, derivative of quotient. First take the denominator and square it. What goes in the top? Derivative of the numerator times denominator as it is minus numerator as it is times derivative of the denominator. So this is your quotient rule. Composition. F compose G, its derivative will be, first take derivative of the outer function F prime, keep the inner function inside as it is, then times G prime. This is the chain rule. What is antiderivative? Antiderivative is going back. For example, antiderivative of cosine would be sine. Antiderivative of sine would be negative cosine. Secant squared, tan. Secant x, tan x, secant x. You understand what I'm saying? The minus I'm not mentioning here. Cosecant x, cotan x, its antiderivative will be negative cosecant x. Alright? And so on. The catch is this one. What is the opposite of this? For the derivative, n comes down and reduces. So for antiderivative, I would have to increase it and divide by n, you see. So divide by my result power. Remember, result power. So anyhow, antiderivatives. Antiderivative of 0 is constant. Well, derivative of constant is 0. So the antiderivative of 0 is constant. Antiderivative of x to the power n. You increase the power and divide by the resulting power. Plus constant. Why? When I take derivative of this, the constant will give me 0 and this will give me this. Likewise, antiderivative of cosine is sine plus constant. Antiderivative of sine, negative cosine plus constant. Notice the table simply switches. Okay, cosine gives me sine going back. Sine will give me minus cosine, minus to compensate for this minus. Secant squared should give me tan going back. Secant squared gives me tan, always plus a constant. So these are the basic antiderivatives. These are the basic derivatives. I have uploaded this in your blackboard on section 3.9. Okay, right underneath it. So I'll continue with the slide in my next video.